Let's take a look at 7-3, proving triangles similar. Go ahead and write that down. Let's take a look at postulate 7-1, angle-angle similarity. Take a look at this triangle and this triangle. Go ahead and write those down. It's showing you that angle S, which is right here, and angle M are congruent. Also saying that angle R and angle L are also congruent. If that's true, we can say that triangle SRT is similar to triangle MLP. Let's take a look what they try to tell us in problem number 1. In problem number 1, they're telling us that triangle RSW and VSW, are they similar? Angle R congruent to angle V because the measure is 45. These two equal 45. So triangle RSW and VSB example B, we're going to take a look at triangle JKL and PQR. We know that in a triangle, all the angles add up to 180. So if we're looking at measure of angle K, which is the angle that is missing, all you need to do is take 180 minus 30 minus 70. That would tell us that the missing angle is 80. Angle measure P, and the drawing over here, is also add up to 180, which means I take the total minus what they've given me in this triangle over here, and I get the missing angle is 25. So triangle JKL and PQR are not similar. Let's take a look at theorem 7-1 and see what that is telling us. Triangle ABC and triangle RQS, they're saying that AB, which is that section of the triangle, and QS, this section of the triangle, if you set that equal, to side AC and QS as a proportion, you show angle A is congruent to angle Q. If we take a look at theorem 7-2, they're saying that if you take side AB over side QR, and then take side AC over QS, you'll find out that BC over RS. Then you can conclude that triangle ABC is similar to triangle QRS. Problem 2, they're trying to show you that is this triangle similar to that triangle. As we talked about earlier, even in the last section, if we knew what sides are equal to each other, you can set them up in a proportion. So in this example, they took side ST, which is this part of the triangle, and side XB over that side of the triangle. If you set them up as a proportion, you get 6 over 9, which reduces to 2 over 3. So one proportion is 2 over 3. Now you need to take a look at another side. And this example, they're taking side US, which is the same as WX on this side, both the hypothesis. Hypothesis. Ah! That's up again. And if you set those up, you get 10 over 15, which reduces to 2 over 3. By doing that, you show that these two triangles are similar because they have the same proportion, 2/3, 2/3, and 2/3. So all sides have the same proportion, so both triangles are similar. Example B, they're taking this picture and separating it into two separate triangles. Trying to show, are these two triangles similar? Again, you need to set them up in a proportion. What sides are the same? So we have side KL, which is 8, KM, which is 10, because we have to take the 8 plus the 2 over here to make this side equal 10. So we have the proportion 8 over 10, which reduces to 4 over 5. We then have to compare another side to see if we get the same proportion. We're going to take a look at side KP and side KN. KP is 12. KN is 12 plus 3, 15, which came from those two sides right there. If we set that up in a proportion, you get 12 over 15, which then reduces to 4 over 5, proving that these two triangles are similar. In problem 4, we're taking a look at two triangles out in the canyon. See if you're given this information along with this information to prove or to find what does this side equal over there. So we're trying to find out what is x equal when you're given the height of this person You're given the distance away. And can you use that information to find out what x is given this information? So if I want to find x, I need to take this point, so that's proportion, 5.5 over x is going to be equal to 6 feet over 34. Just like we done in the last section, I need to cross multiply these two numbers and find out what x equals. So I would have 6x equals 187. If I want to get x by itself, I have to divide both sides by 6 to give me x equals 31.2, which we would just say the height of that is 31